when you look at this once again, in the triangle ODC similar to OBA, DOC 125 degrees, CDO 70 degree. Here, this concept you have to use. ODC similar to OBA. That means D is equal to B, C is equal to A, and O is equal to O, vertically opposite angles. Since 55 and 120, see this angle, these two angles are linear pair, so we use that one. This is the linear pair, DOC plus BOC. DOC plus BOC. Using that linear pair, we got DOC is equal to 55 degree. We got this one 55 degree. Then angle sum property. Use the angle sum property here. So sum of three angles of the triangle. In triangle DOC, we have three angles: DOC, ODC, OCD. Angle sum property, and we already calculated this DOC 55 degree, and it is given 70 degree. So substitute here, and you will get angle OCD. OCD is equal to 55 degree. But OCD and OAB are also equal. OCD and OAB are also equal. They are the corresponding angles of similar triangles. Since these two triangles are similar, these two angles are also equal. So hence we calculated all the three angles of this given question. Now let's go to the next question. Question number 3. Look at the diagram now. So here, diagonals AC and BD of a trapezium, given ABCD is a trapezium, remember that. Trapezium means one pair of sets are parallel, with the AB and DC parallel. They intersect each other at the point O. Using similarity criterion of two triangles, show that OA by OC is equal to OB by OD. So here in the data, so what is given here? Given ABCD is trapezium. ABCD is trapezium with AB parallel to DC. Okay, these two sides AB and DC are parallel to each other. Now, as for this, since these two lines are parallel, you can write alternate angles are equal. So you can go to the proof. So you can write angle ABO is equal to ODC. Angle ABO is equal to ODC. So you can write alternate angles. Because AB is parallel to CD. Similarly, so we wrote these two angles are equal. Similarly, I can write these two angles also equal. So what is that? Angle BAC, angle BAO is equal to angle OCD. Angle OCD. This is also same reason. So now by AA similarity, we can write these two triangles. By AA similarity, this triangle and this triangle are similar. I can write angle AOB, triangle AOB, similar to triangle. For A, which is the corresponding angle, it is C. So in place of A, you write C, O with O only, and for B, the corresponding angle is D. So you can write COD. AOB similar to COD. This is by AA similarity. So what we need to prove? We have to prove that OA by OC. We have to prove that OA by OC is equal to. Look at the question now. Once again, we have to prove that OA by OC is equal to OB by OD. So you have to take the sides proportionality here. Since the triangles are similar, I can write the sides are similar. So I will write OA first two here by OC. OA by OC, these two, and then OB, so OB by OD. See, we have taken first two, here also first two, OA by OB, then the last two OB, and here last two, OB by OD. So we have proved that OA by OC is equal to OB by OD. This is what, so corresponding sides are proportional, because sides of similar triangles are proportional. So this is what we have to prove here. Look at this fourth question now. In this given figure, QR by QS Observe the diagram carefully. QR by QS. So look at this. QR by QS is equal to QT by, instead of QP, you are having PR. Thales theorem. Recall that Thales theorem. QR by QS, this ratio. QR by QS. Okay. This longer side and shorter side. QT by PR. QT by, instead of QP, QT by QP means that is required, but we are having PR. So this is something need to be changed here to use Thales theorem. And so this is, keep in your mind, this one PR you keep in mind. Come to the next data. We have angle 1 is equal to 2. Something you can use from this. Angle 1 is equal to angle 2. So these two angles are equal. What you can write from this? Given. So in the question, what is given? Let us write first. So in this question, QR by QS is equal to QT by PR. QT by PR. And again, angle 1 is equal to angle 2. We need to prove that triangle PQS similar to triangle PQR. Proof. Now look at this. In triangle PQR, angle 1 is equal to angle 2. Given. In the triangle PQR, 1 is equal to 2. It's an isosceles triangle. The sides opposite to them should be equal. Therefore, I can write PQ is equal to PR. I can write PQ is equal to PR. We call this as 1. Equation 1. Now, we have QR by QS is equal to QT by PR. Now, substitute 1 here. From 1, this QR by QS will become QT by, instead of PR, what you can write, this is what we don't want here, PR. So you can write here PQ or QP. So now we got, look at the diagram. What we got here with reference to the diagram, you see QR by QS, this longer side by this shorter side, then QT by PQ, QT by PQ or QT by QP. What you can conclude from this one? QR by QS, QT by QP. What you can conclude? Two sides are proportional here. QR by QS. QR is the side of this bigger triangle. QS is the side of this smaller triangle. Similarly, QT is the side of bigger triangle, QP is the side of smaller triangle. Which are the triangles? So PQS and QTR. So in triangle PQS and QTR. So let us take in triangle PQS and in triangle TQS. Look at the diagram. TQR, PQS and TQR. So in these two triangles, we are already having QR by QS is equal to QT by PQ. Another angle, look at this. So in this triangle and in this triangle, an angle is common. Identify the angle which is common in both the triangles.
Angle Q.
Angle Q. So I can write angle PQS is equal to angle TQR. Angle PQS is equal to angle TQR. So it's a common angle. So this is, we have proved. So now look at this, two sides are proportional and the angle also equal. Therefore I can write triangle PQS similar to triangle. So PQS, look at the diagram. PQS, PQS, similar to corresponding sides, TQR. So therefore I can write here PQS similar to triangle TQR. So this is what we wanted to prove here. So look at the diagram once again here. Here in the question they have given QR by QS. Then QT by, instead of QP they have given PR. Now again angle 1 and 2 are equal. Therefore you can write PR as PQ. In place of PR you can change this as PQ. So now we look at this, what happens? QR by QS, QT by QP. This is QP only. So two sides of the two triangles are proportional. And again in the bigger triangle and in the smaller triangle we have angle 1 is common. So Q is common. See, PR by QS, QR by QS, QT by QP, and angle 1 is equal to angle 1 common side. Therefore by SAS similarity the two triangles are PQS and TQR. PQS and TQR are similar. So you can write here by SAS similarity. So this is by SAS similarity. Is it clear? You understood this or not? Now if you look at the fixed question, S and T are the points on the sides PR and QR. PR diagram is like this, PQR. S is a point on side PR, T is a point on side QR. Carefully you have to write, diagram is not given, so therefore we have to write the diagram. S and T are points on the side PR and QR. So on the PR I have taken S, on QR I have taken point T and joined this S and T such that angle P is equal to RTS. Angle P, this angle P is equal to RTS. Okay, show that RPQ similar to RTS. RPQ, this bigger triangle, similar to RTS. RPQ, RTS. Tell me, to show that the two triangles are similar, at least you have to show two angles equal. RSAS. Which one you can use here to show that RPQ, RTS? They have given one angle equal already. One more. AA similarity we can use here. So here you write what is given. So given in triangle RTS, so this one, RTS, angle RTS is equal to P, angle P. This is what is given. So now in triangle RTS proof, let's go to the proof. In triangle RTS and PQR. In triangle PQR, so we have one angle RTS is equal to P, I will write it as angle P, RPQ, I will write it as RPQ, same as P. So this is given, one angle equal. Now in the triangle RTS we have this angle, and in PQR also we have angle R. So how to write RTS? So this I will write TRS. Angle TRS is equal to TRS. I will write QRP. So QRP. So it's a common angle. So common angle. So therefore by AA similarity, triangle RTS similar to triangle C. For R, same angle R. In place of R, you have to write R only. So R only. In place of T, T is equal to P. So in place of T, we have to write P. Then in place of S, then which is the left out angle? In this triangle, S is the only angle left out. In the bigger triangle, we left it only Q. So therefore, in place of S, you have to write Q. So therefore, triangle RTS is similar to RPQ. RPQ similar to RTS. Sixth question. We have triangle AB congruent to triangle ACD. ABE. What is the triangle ABE? So I am going to highlight that in this diagram. ABE. So this is the triangle. ABE is a triangle, given triangle, which is congruent to ACD. So ACD means this triangle. Okay. So ABE and ACD are congruent. Congruent means all the parts are equal. You have to show that ADE is similar to ABC. ADE similar to ABC. This small triangle similar to ABC. Given these two triangles are congruent, you have to prove that ADE is similar to ABC. So now, what is given? Let us write now. Given triangle ABE similar to triangle ACD. Triangle AB is similar, congruent to these two congruent. To prove, we need to prove that triangle ADE similar to triangle ABC. We have to show that at least two pairs of angles equal. So proof. So given that triangle ABE is congruent to triangle ACD means all the corresponding sides are equal. So I can write AB is equal to AC. AB is equal to AC. Look at this diagram. AB is equal to AC. Similarly, AD is equal to AE or AE is equal to AD. See, AB first two, here AC first two. AE first and last, here AD. So because these are corresponding parts of congruent triangle, CPCT. Corresponding parts of congruent triangle. So what I can write? AB by AC. AB by AC is equal to 1. We can write transfer AC to the denominator. AB by AC is equal to 1. Similarly, I will write here instead of AD is equal to AE, I will write AD is equal to AE or AD by AE is equal to 1. Transfer AE to the denominator. You will get AB by AC is equal to 1. Then AD by AE is equal to 1. Since both the right hand sides are equal, so I can write AB by AC is equal to AD by AE. Okay, you can call this as 3, this one 1, this is 2. From 1 and 2 you are getting this one. Look at the diagram now. AB by AC. AB by AC, I am getting AD by AE. Now I will make some rearrangement with this one. Transfer this one to the left side, AD. AB by AD is equal to AC by AE. What arrangement I have done, you look at this one. AB by AC is equal to AD by AE we got. What I did, I transfer AC to the right hand side, the numerator, and AD which is in the numerator to the denominator. So AD reaching here, denominator. Then the AC which was here going to that side. Now you look at this one with the diagram. So now you look at this one with the diagram. AB by AD. AB by AD, AC by AE. AB is the side of bigger triangle, AD is the side of smaller triangle. Similarly, AC is the side of bigger triangle, AE is the side of the smaller triangle. We got two sides are proportional. AB by AD, AC by AE. One angle you have to show, which must be an included angle. AB by AD, AC by AE, and this angle, which is common in both the triangles. Angle A is common in ADE as well as ABC. So therefore, I can write here, okay, so I can write angle A is equal to A, which is a common. Instead of writing angle A is equal to A, you can write correctly So angle BAC is equal to angle BAC is equal to angle DAE. Angle BAC is equal to angle DAE. Angle BAC is equal to angle DAE. Say two sides are proportional, one included angle equal. So therefore, by SAS similarity, so we can write what triangles similar. Look at the diagram. By SAS similarity, I can write ADE similar to ABC. So I can write ADE, triangle ADE similar to triangle ABC. As the proof.